Welcome. Thank you so much for stopping by. We are Planar Motor. What we do here is we develop planar linear motors based on magnetism. And so what we have here is just our demo setup, which is running. Our product here is our flyways, which is the powered component, and then we have our movers on top. Now, the movers are a passive magnet system. So within this mover, there is permanent magnets, and so zero sensors, fully passive, and then the flyways themselves is where we get our power. So under the surface of the flyway, we have a proprietary array of coils, and as the coils are triggered and powered up, what they do is they will interact with the magnetic field from the permanent magnets underneath the movers here. So if we actually look down here, we can see that there is no basically interaction or mechanical touching between the movers and the flyways. So this means that it's a frictionless system. As well, it reduces the amount of wear, so you're not going to have to be replacing the tops of these. As well, if you get dust, if you get oil, if you get water, it's not going to affect the performance at all, and it will just fly right over top. As you can see, we actually have a business card right down here, and that's just sitting right underneath there. The best thing about having the passive system and the coils is that between the two components, there is no moving parts, which means that there is no required for maintenance, there's no wear, as well, so that means that there's no shutdown time or having to basically maintain and stop production. This one here, it's completely scalable. This, our demo setup, is just a small little unit, though it can be anywhere from a singular flyway and a singular mover up to 1,000 flyways attached in series, whatever configuration you want for each controller. Now, if you're going to be doing a larger factory setting or production line, you would be able to connect multiple controllers, and then they would just automatically communicate with no stopover or no disconnect between the flyways here. So these movers that we're looking at here, this is the smallest variant of the movers that we have. They have a payload of 600 grams. So this is the payload for their maximum performance. So this is a motion of 2 meters per second of velocity and up to 2 Gs of acceleration. At the rated spec, it is able to have a positional accuracy of plus or minus 5 to 10 microns with a system such as this, which is uncooled. Though, with the proper cooling techniques, such as using our water cooling ports, as well as proper calibration, you can decrease that tolerance band to the best, which is going to be plus or minus 1 micron of positional accuracy. Though, if you were going to be carrying heavier objects or wanting larger payloads, then we do have 11 different sizes of X-bots or movers that can be used. So this is quite to scale here, and the largest size that we have available can hold up to a payload of 14 kilograms. So that's about 30 pounds. And that's also at the maximum performance here. As you can see, we are integrating with auxiliary automation equipment, such as this Mechademic robot. Everything is connected here through the use of a PLC, so it can be automatically integrated in through the use of just integrated programming. With the unit, you will get the PMC, which is the controller, as well as our software, the tool, which allows you to configure the orientation and layout of all of the flyway modules. Though, you are able to, we have internal libraries built in so that the software engineer that is going to be programming it is able to use a variety of different languages, programming languages, such as C++, codices, Python, as well as engage with all the standard industry big names in automation, such as we have compatible, like Rockwell, Beckhoff, Siemens, Keyence, As well, they can be connected via communication with Ethernet PowerLink, Profinet, MCAP. Yeah, and so this is the system here. It is quite versatile. We have uses in a variety of different industries, from automation, pharmaceuticals, filling, assembly lines, or just conveying. And one of the best things about this is that for an automation system, this can either be the next step in automation, so it can be the connect between two separate machines that basically goes from a semi-automated to a fully automated system, or it can be the first step where you can basically design this system around the requirements and new kind of automation setups that you're bringing in. Yeah, I believe that is. Oh yes, and sorry, and just as a conveying system, if we are wanting to, move material in assembly lines, let's talk about the configurability. Unlike traditional conveyor systems where it's a unidirection, these here are able to move in 6 degrees of freedom. So that means moving in the X direction, the Y direction. We are able to change the elevation height from 0.5 millimeter up to 4 millimeter, as well as do full rotation and rotation in the yaw and pitch of the plate. So this kind of gives full movement and tracking. So, and the last thing here, all of the movers do have an internal RFID chip, meaning that we are able to track and know exactly where each of the movers are at any given point. And so this is great for quality assurance, for basically keeping control. And then say you had a vision system that indicated that a part was bad or something was wrong, you'd be able to correctly handle that and basically deal with that system. But yeah, so that is pretty much the Coles notes of the system. Hopefully this gives you all the information that you need, and let us know if we can give you more information or work to create a solution.